Bismillahirrahmanirrahim. Today we are going to talk about the commutation relations. Since x, y, z mutually commute, it means if x and y are written in this form in square brackets and they have answer equal to 0, then these both x and y will commute each other. So do pxy, px, py, and pz. It means different positions x and y are the position components are equal to 0. It means commute. Similarly, we can check what will the results of px and py, px and pz, and any two operators can be commute or they do not commute. You can check. If two operator commute, it means they have same eigenstates. Let's start from this example. A similar problem we have solved earlier in Heisenberg uncertainty principle. X and Px, these are two operators. When operating on psi, then it can be written as xpx minus px x psi. Px is further can be written as minus iota h bar partial psi over partial d. After doing the simple mathematics, we achieve these results. It means x and px do not exactly commute. Similarly, you can do y and py is equal to iota h bar, z and pz is equal to iota h bar. Now, uh, if we commute x with lx, lx is here the momentum, x component of momentum, and x is here for the position. You know, Lx is equal to y pz minus that py. Then it can be written as in this form xy pz minus that is. But using using the this relation, this formula, if a comma bc are in square brackets, then it can be written as b and a and c in brackets and plus a and b in brackets and into c. By using this relation, you can do these things. It means Lx and Lx both commute each other. Answer is equal to 0. Uh, if these two operators have answer equal to 0, then x component of both uh, position and angular momentum can be measured simultaneously. The physical significance of this. If both operators commute, then they have the same set of eigenfunctions. They share the eigenfunction and they can be measured simultaneously. Similarly, you can do x and ly. Just simple mathematics. I have told uh, that you can do just by using this relation. This relation is very simple mathematics, and then we can get x ly is equal to this one. It means they are not commuting each other or two operator or non-commuting, then they do not have they do not share the same set of eigen functions and cannot be measured simultaneously these two operators, because here the result is uh, not equal to 0. Similarly, for x and Lz, we have this one. You can do yourself. You can make the you can do the practice of these operators. And if answer is equal to 0, then these are called commuting. If answer does not equal to 0, then these are non-commuting. Here, commutation relation between position and orbital angular momentum L represent that these two operators commute when operators have a same component, just like x and lx, y and ly, z and lz. But other components are not commuting, just like here the x for position and y is for the angular momentum. Answer is not equal to 0. Similarly, we can do px and lx, linear angular momentum and angular momentum, but x component of both. Then we have this relation. You can do this mathematics by using this property, by using this relation, or you by using this mathematical relation. If you use these both mathematical relations, you can achieve this result equal to 0. Px and Lx, it means they commute each other and they share the same set of eigenfunctions. Similarly, if we commute the x component of linear momentum and y component of angular momentum, then we have this type of result: iota h bar p z. These are simple examples, are simple mathematics. Similarly, for px and lz, we have this relation. You can do yourself this time, and you should complete these commuting and non-commuting and submit these results to me within few days. Similarly, Lx and Ly, if these are two commuting brackets, we can expand this way by using the mathematical relations that is achieved here. By using the mathematical relation, this one, I think this one, by using this mathematical relation here, just AB, CD, and then expand these. And after expansion, the same, then they have sometime will be cancel out. If x and px both are same, then answer will be 0. Then ultimately we have this result. You can think over this mathematics. It's not difficult. You can discuss if you're feeling some difficulty to solve this one. And similarly, this is just a matter of practice. You can do this. This have this result. PXL and L square have this result. There, it means in this lecture, uh, you have to make the practice of commuting and anti-commuting bracket. No need to cram or memorize. Just make the practice. It's a very simple topic.